transformations of functions that affect the y value. A transformation is a change in the function, such as a movement, which could be up, down, left, or right, a stretch, vertical or horizontal, or a flip over either the y or the x-axis. The nice thing is that if you know how a transformation affects one function, you know and understand how it affects all functions. Because what a transformation does to one function, it will do to every single one. So let's suppose that y equals f of x is a function. There are four main ways to mathematically transform f. Two of them will affect the input, or the x's, and two will affect the output, or the y's. So the four main ways to mathematically transform f will be written with different variables, a, b, c, and d. And each one of these will affect a function slightly differently. Notice here that the a and the d are affecting an output. That is, they're going to affect the y's. And you might say, well, how do I know they affect the output? Well, it's because the input into f of x is what's inside the parentheses. So inside the parentheses is the input, and outside the parentheses is the output, which means that b and c are going to affect the input, or the x's. In this video, we're going to look at what happens when we multiply our function by a number, that is a times the function, or if we add a number to the function, that is the plus d. Let's take a look. And I'm going to start with a parabola, because most people understand the shape of a parabola and kind of how parabolas move. And if I understand how the transformations affect the parabola, I will understand how they affect all functions as well. So let f of x equals x squared. And in case you're unsure what the shape is, let's plot a few points. When x is 0, so is y. When x is 1, y is 1 squared. And then we can just plug in some values. 2 squared is 4. Negative 1 quantity squared is 1. Negative 2 quantity squared is 4. And then we can plug these values, or plot these values on our graph over here. And then connect our dots. There's my basic function, y equals f of x equals x squared. What if I wanted to draw 2 times f of x? So just a note, that's like the a up here. We're multiplying the function by some number. Well, notice that we're doing 2 times f of x, which is really 2 times the y values. So let's change the color on that. So when x is 0 and y is 0, 2 f of x is 2 times y, or still 0. And then x is 1, y is 1. So 2 times our y is 2, etc. And so if we plot these points, notice that my vertex, kind of my starting or my center point, doesn't change. But these other values do change. And if I were to connect the dots now, like this, notice what we have. Sometimes we call this a vertical stretch. Our graph gets stretched. Sometimes we say it gets narrower or skinnier. Certainly it would have if I could have drawn it a little bit better. But I like to say the graph is growing 2 times as quickly. And that's certainly the way I think about it in higher levels of math. Now, what if I wanted to do something like 1/2 f of x? Again, we could go through and take our original values of y and multiply them all by 1/2. And then plot the points. And will look like this. Sometimes we say the graph is a little bit wider, but I like to think of it in the following fashion. The graph is growing 1/2 times as quickly, or 1/2 as quickly. So this number out front that's being multiplied, so if I did, the red one would be 1/2 times f of x, or 1/2 of x squared. And the blue graph will be y equals 2 times f of x, or 2x squared. And that's going to affect how fast the graph grows. Or, mathematically, we're simply taking our original function and multiplying the y values by whatever number's out front. Now, what if we multiply by, say, -1? So what if I want to do y equals negative f of x, which would be negative x squared? And let's go ahead and redraw our original graph. Maybe not with all the details, but something along these lines. What would y equals negative x squared look like? Well, the same thing that we did before we can do here. We can take our original y values and multiply each of them by -1. So 0 stays 0. Our 1 becomes -1. Both in x is 1 and x equals -1. The y of 4 becomes -4. And then let me change the color. Let's make that green. And this is the graph of y equals negative x squared. So what did multiplying by -1 do to the graph? Well, you can say it flipped it upside down. More mathematically, we took all the original y values and made them negative, and the result was to flip the graph upside down. So multiplying by a number outside here always affects the y values by that new, by the new product, if you would. Now let's take a look at the other transformation that affects the output. So we already looked at the a times f of x. Let's look at the one at the end, plus d. And we'll start again by plotting our original function. Like that. And we had our values. I'll change the order of my x's. And what if I wanted to find f of x plus 2? How do we do this? Well, since f is y, it just says take our old y values and add 2 to get the new y value. So 0, which is my original y value, becomes 0 plus 2. 1 becomes 3. 4 becomes 6. Just take your old y values and add 2 to them. And then we can plot it like this. So what did this do to the graph? Well, if I could have drawn it really well, you would see that it does not make it either wider or skinnier, doesn't grow any faster. It just simply got moved up 2 on the y. So without my help, what would f of x minus 1 look like? If you said it takes the original function and moves it down 1, you would be absolutely correct. Neither wider nor skinnier, no sort of stretch, simply the graph got shifted down 1 space. So consider the graph of f of x, which is shown and is composed of 2 line segments. Let's draw the graph of 1/3 f of x plus 1. How would we do this? Personally, I recommend that we do this in stages. And we're going to use our order of operations. That is, we'll do the multiplication first and the addition second. So if this is my graph of f of x, 1/3 f of x says take your y values and multiply them by 1/3. We're not affecting the x's, just the y's. So if I start over here at -2, 0, 1/3 of 0 is still 0. We'll go to our next major point, 0, 3. The x doesn't change, it's still going to be 0, but the y value gets multiplied by 1/3. So it would become, instead of 0, 3, it would be 0, 1. This point right here, which is the point 3, 0, the y value doesn't change because 1/3 of 0 is 0. And then our last point, the y value would become -1. So I'm going to draw this with a dashed line because this is not my end result. All I have done so far is taken care of this first part, the multiplication. Now what do we do? Well, it says, let's take what we have and add 1 to every y value. So my x is not changed, but my y is increased by 1 for every y value. And then we can connect our dots like such. And this will be the graph of 1/3 f of x plus 1.